Hello and welcome back to Dr. Logic Awkwardly Does Logic. This is our third video in our series of digressions on systems S1, 2, and 3, the systems of strict implication that Lewis developed that for various reasons are not really talked about very much anymore. So let me bring up the whiteboard because we need to first define what S3 is. And as with the other systems, it is defined on the basis of the previous one. So it is an extension. S3 is S2 plus the axiom necessarily if it's necessary that P implies Q, then it's necessary that possibly P implies possibly Q. Now, last time I said that systems S1 and S2 are what are called absolutely strict. They have infinitely many distinct modalities. System S3, on the other hand, is what is called a complete modalization. And that just means it's not absolutely strict. There are, in fact, finitely many distinct modalities in S3. In fact, there are 42 of them. There's the null modality, when we don't have any modal operator, negation, and then the proper modalities, 20 positive ones and 20 negative ones. So we can see that by moving along kind of up this chain of logics, we are getting closer and closer to the things that we are familiar with. Nevertheless, S3 still remains a fundamentally weird system. In fact, it is what Halden calls an unreasonable logic. Now, you might be thinking, logic is supposed to almost by definition be reasonable. It's about reason, it's about rationality. How can you have an unreasonable logic? He gives a precise definition of what it means for a logic to be unreasonable. So a logic is unreasonable if there are formulas phi and psi such that in the system, phi is not a theorem, psi is not a theorem, and phi and psi share no variables. So there's basically nothing in common between the two of them, but the disjunction between the two of them is provable. And that is pretty unreasonable. So the particular case, and I'm sorry, I can't go into all of the details of why the disjunction is provable, why the other ones are not. This would involve a much bigger digression into the Lewis systems than I'm going to do at this point. Maybe we'll come back in the future. But the witness to the unreasonability is this theorem, which is a theorem of S3, says that if it's possibly possible that either it's possibly Q, or it's necessary P implies necessary P. So I will leave you with that strange little theorem and that unreasonable little logic. And we will circle back to talking about S4 and S5, the popular kids of the modal logic world. But I hope you enjoyed this little bit of a digression into some weird little systems that don't necessarily fit within the sort of ordinary modal logic setting, but without which we might not have modal logic as we understand it today. So, hope you enjoyed it. Take care and see you soon. Cheers.